Welcome to the Valve Studio for March 13th, 2016. I've got a lot of replies back from my numerical stimulation and optimization used in SciPy to look at these two characteristic plots from data sheets from the 50s and optimize the parameters so you can use the models for circuit simulation. I got two replies back that are very interesting. The first one was Minnows. Minnow is the author of this book that I always kept referring to from his high-end valve amplifiers too. Remember, I went through chapter 1 in that book kind of extensively. He said that I might be the first person that actually went through and verified his findings, and so I'm glad I did that. It took me 19 years to get to that point, but here we are. The other reply I got back from was Patrick. Patrick used to run Turner Audio in Australia. Patrick is very verbose in his emails, and I'm very thankful for that. He goes through, and I'm gaining a lot of knowledge from his decades of experience. So I read a lot of his things and figure out exactly what he's saying. And to sum it up, Patrick is an advocate for stop using the computer and actually build something, which is fine. I knew I was going to do that at some point. It just happened a lot sooner than I was planning on, because I knew I was going to have to set up this lab to teach this class, and I needed to do it, so I did it this weekend. What we have here is this room here is my office, and originally I just wanted to have my office in here and no equipment, no anything else, no storage of stuff or anything. But this room wasn't really used that much, so this is my personal research facility now. The other room that you see in some of the other videos, that's my lab. I didn't want to endanger my day job equipment over in my lab with the high voltages that I'm going to see in my tube design, because I can't afford to have that equipment be accidentally destroyed for whatever reason. Plus I have a lot of long-term experiments running over there that I didn't want to have to disconnect to actually record these videos as well. So I cleaned up in here a little bit the last couple of days, set up this workbench. It's made out of wood. Remember, we're going to be working at maybe 500 volts of things in here, and I didn't want to. I don't want to burn anything up. And I brought in some of the equipment I've been purchasing for the last I don't know, probably 18 months. I've been buying various pieces of equipment. I get it at various places. We'll go into this in a minute. What I wanted to talk about was specifically about, let's go back to these tools. There was two motivations for me to use the SciPy's optimization and F-solve routines. One was I wanted to learn how those libraries worked, and because what I've been using for the last, I don't know, probably 25 years is a thing called TK Solver. That was a numerical simulation tool that I used to use on my Macintosh when I had one in the 80s. And I still use it today. I actually boot up an emulated version of the Mac, I don't know, probably a Mac Plus for System 7. And I run TK Solver, and I can't ask some of my students to do that. Plus it's vintage, but that's really a simple program to use. It's really elegant. And there's nothing like it. MathCAD's not like it. Nothing's like TK Solver. Because it uses a nonlinear solver and various routines, and it basically runs perhaps an iteration, or it does various kind of things, and it's perfect for doing analog circuit design. SciPy's optimize and F-solve routines are going to be very similar to the way that Python works, plus those are current and up to date, and as you saw in the last video, we can actually distribute those without doing any software install, using the tools for the My Notebook and that kind of thing. So that's good, because I want to figure out that part out so that people can have these numerical tools. Dr. Allen's philosophy is that you need to understand the design before you go through and actually do the simulation. Don't use simulation as a tool. That's bad philosophy. And then we don't want people to jump right to SPICE and actually tweak parameters in SPICE and rerun it again. That's hacking. We want to teach a theory behind design and then use SPICE as a verification of your design. And these tools are design tools to help you with the design prior to doing either the lab work or circuit simulation. And I wanted to pick a simple enough problem. The curve fitting thing is really kind of simple, because I want to use the same tools to look at output transformer design and how that couples in with the output tube itself, or the output tubes for push-pull. And that Minnow spends a lot of time talking about that. In fact, that's been his area of expertise for the last 20 years, as well as Patrick Turner. I mean, that guy's spun, I don't know, probably thousands of transformers. He did mention in his email he's built 50 amplifiers in his day, and I'm not going to get that kind of experience here. Well, I hope to, but I don't know what's going to happen. I'm just excited about doing something new. So I posed a kind of a question, or something was brought up in both those emails. Actually, in Minnow's book, he has a whole chapter on an amplifier called a Quad 2, and Quad 2 was designed by somebody named Sir Peter Walker. Minnow goes through and he talks about the Quad 2 design in quite a lot of detail about the nuances of how that's put together, and actually how you don't want to do mods to that design because it's perfect in and of itself. Patrick also mentioned the Quad 2 in one of his long emails. And so I posed a kind of a question to Minnow. I said, did these people, like this Walker guy, did he know the math behind all this stuff? Did he know the Childs-Langmuir equations and actually use those and design that in with the magnetics and the coupling and all that kind of stuff? Did he work those things? Or did he just sit down at a bench like this and iterate out a design? And Minnow said, no, some of those masters actually knew all the math, and that's what made those amplifiers great. Now Patrick says that amplifiers like that did exist. They really are the best amplifiers that existed, but those things were designed without using computers. So why focus on doing simulations? You need to get to the bench more. That's his common theme. Would you get to the bench more? And I'm like, okay, because his passion, he's trying to impose upon me his passion so that I can see that I need to get the feel of it. A lot of tube designs are about feeling your way through it and actually knowing what's going on with that. Because what's interesting to me is that in transistor design, you have the luxury of regulated power supplies. You have the luxury of transistors actually somewhat adhere to their manufacturing specifications over their lifespan. There's not really an output transformer per se, so you're driving everything really directly from a really low impedance output source. And that's kind of a luxury. Now, the tube amplifier is completely different. The tube's age, the power supply's got sag to it, the output transformer coupling, and the output transformer design itself is a factor. Now you take all those things and you couple that with a loudspeaker that somebody has this version of something or other and somebody else has this one over here. It's going to be completely different. And then you take all those variables and you throw them into a room Like this room would be horrible for audio. But you put it in somebody's living room and that's going to sound different than somebody else's living room. So what's the point of it all? In Minnow's paper for AES, he talks about the ear's perception of frequency response, and how the notion of linear frequency response between 20 and 20 kilohertz, that doesn't matter. Then he also goes in, and this is the two interesting things that come out of his discussion was, sometimes you want to design the output transformer so it does introduce a little bit of distortion, particularly on the low frequencies, because that was perceived by the ear as a more pleasing sound. So make your transformers intentionally add a little bit distortion on the low end. And this is just like foreign to me because I've always been driven by specs, but none of that matters, right? The other thing that Minnow talks about is the perception of the way our brain receives higher frequencies between 20 and 40 kilohertz, between 30 and 40 kilohertz, and how it's really important that you design tube amplifiers to go all the way out to 80 to 100 kilohertz, even though your ear can only hear to 20, maybe. My ears are shot now. I mean, I might be able to hear to 12. I don't know. I'll have to figure that out. But yeah. So what does it matter? I don't know. I don't think it does. I think we just need to make some stuff in here and see how it goes, and teach a lot of people along the way, because we need to further the ideas that came out from all the way from 1911. The future generations, that they might be interested in this stuff, and so we need to create some content to actually teach them how to do design. That's why I'm here. Let's talk about my gear here. All right, so like I said before, I bought most of this stuff at I either bought it at a garage sale, an auction, or an estate sale, and I'll just show you what I ended up picking out of my vast supply of junk stuff. I don't want to call it junk, because a lot of this stuff is not junk. Like I said, I built my bench out of a door that's wood. I don't want any shock hazards if I have circuit boards stuck right on this wood. And what I have, let me see, if we start, let's start over here. This is a Variac and my little light bulb tester for looking at shorted amplifiers or radios when I want to first power them on. I can run it through that light bulb and do its current limiter. Down here I have a General Radio decade resistor that I got this at an estate sale in Los Alamos. This is a Simpson 260. This is an old analog meter. These guys here are the workforces of the technicians from the 50s and 60s. I do have these two pieces here. I had these for a long time. This is an old Craftsman digital multimeter, and this is like a cheapie that if I blow it out, it's fine. And I have my old Weller soldering iron that I got when I was in high school. And this thing over here, this is a 4 ohm speaker that's probably vintage, like 1950-ish. It has a paper cone and a paper surround, so it's going to be an open back. So this is going to represent the speakers of the day. This is also 4 ohms. Up here I have a Polk Audio 8 ohm. This is a modern day bookshelf speaker. These things here are something I also got at that estate sale in Los Alamos. These are HP clip-on DC milliammeters. These things are great. I got 2 of these and they work awesome. I'll publish a link to what these are. I'm not going to use these in the class because people won't have access to anything like this. But I do have these here, so when I'm doing tube amplifier design, I can, or I'm doing tune-up or biasing for guitar amplifiers, I can use these things and actually get the push-pull biasing balanced. I got an old function generator here. This guy's got things to look out for on this. It's a 600 ohm output, not a 50 ohm output on that. Banana plug binding posts. I have an old HP scope here. This guy is probably a 10 megahertz guy. the nice scope that I have in the other lab, I really can't afford to have it go or blow it up. And I actually got 2 of these at that estate sale. One of them works, the other one doesn't. So I have one for spare parts. I really am going to be careful, but if I blow one out, I can actually repair it, and I'm not too concerned about that. Got my textbooks here, and this is a thing I bought at a garage sale in Uray. This is a leader distortion meter. I haven't actually used this. I knew that I bought it a while ago, probably 10 years ago. I never even turned it on, so I don't know how it works. Well, I know how it works, but I don't know if it works. We'll have to see that as well. Up here, this is the thing that started it all. This is my little Panasonic AM radio. This is what got me interested in electronics. So there's some. This is the gear that I have that I just kind of pulled out of my lab today to put on the shelf here. I do have a lot of other gear, but I think that this is enough to get me started. I'd like to get a few more things in here. There's and I need to make some improvements to the room. The lighting in here is great for debugging, but it's horrible for video. So I'm gonna have to get a light box for that. I want to have an overhead camera that's on a track. So I've been thinking about how to do that. I've been looking around because I want to be able to do a bird's eye view of what I'm working on the bench. So I'm going to get that. Before I actually start doing amplifier design, I'm really behind on fixing AJ's Gibson. He's got a Gibson Explorer amplifier. It's a GA15 RVT. I went through and I worked on that sometime in December and got it mostly running. But then again, he came over and turned it up, and it started doing a bunch of crap. And it's been sitting on my floor in there for about 3 months now. I'm really embarrassed that I haven't got to that. I'm going to fix that one first, and then I'm going to. At some point, I bought this old turntable at a flea market or something. It's called a Mectron. Here's a picture of it right here. I'm going to take this. I'm not interested in making a turntable. I want to make a practice amp out of it. I think it's going to be it's got 2 tubes in it now. Well, it's got 3 tubes. It has a preamp tube, which is a 12 SQ7. That's a triode with a dual diode in it. That's actually used in AM radios. The diode sections aren't used. And it has a 50L6 and I think a 35Z4 is a regular diode. So it runs a half bridge rectifier. It doesn't. This turntable doesn't have a power transformer. It's just coupled right directly to the AC. So I have an isolation transformer for it. I want to go through and actually rework this thing, and I want to use this as a reference design to actually look at various performance aspects of it. Maybe change out that XQ7 for another twin triode, and actually up the amplification on the preamp stage a little bit. That's my plan. I want to get set up here. I'm going to continue on my quest to build up my Valve Studio so that we can teach people how to do tube amplifier design. Thanks for watching. This is the Valve Studio for March 13th, 2016.